Hello everyone, so in this video we are going to solve a question of LeetCode. It is combination sum 4. So let's start with the problem statement. Given an array of distinct integer nums and target integer target, return the number of possible combination that adds up to target. So basically in this question we have given a nums array and a value of target, and we need to find out all the combinations of the numbers given in the nums array which adds up to the target, right? So let's quickly see the first example. So in the first example we have 1, 2 and 3 and target is equal to 4. So let's write the same example here. We have given 1, 2 and 3 and target is equal to 4, right? And now let's see what are the possible combination, and we can take this number any number of them, like we can repeat the numbers again and again in the combination. So let's say in this, if we take, let's first take 1, right? Let's take 1. So for this one we will be remaining target is equal to 3, right? We have already taken 1, it means the remaining target is 3, right? So for this remaining target we again have three possibilities. We can either take 1, 2 or 3, right? So let's say if we take 1 again, right? So now we get t is equal to 2, right? Now again for this 2 we have two possibilities, right? We cannot take 3 because 3 is exceeding the limit of 2, but we can take 1 and 2 here, right? So let's quickly take 1 again. So for this the remaining target would be 1, right? Now again we have only one possibility 1, so let's take 1 here and target is equal to 0, right? Now this is the one combination. Now if we go back, then here we have target 1 and here we have target 2. So for this target 2 we have one more possibility, that is 2. So for this 2 we will get 0 here, right? So this is also one possible combination. Now again we go back to t is equal to 3. For this 3 is equal to 3 we have two more possibility, that is 2 and one more possibility is 3, right? So for this 2 we have remaining target is equal to 1, and for this 3, right, if we take 3 then we have remaining target is equal to 0. So it means we have got target 0. It means we have completed the limit and we have one possible combination as 1 and 3, right? And for this t is equal to 1 we will get 1 and this is t is equal to 0, right? So for this if we take 1 as the first element, then we will get this possible combinations, right? Now let's take 2. So if we take 2, then we will get t is equal to 2, right? So for this t is equal to 2, again we have two possibilities, either we can take 1 or we can take 2, right? If we take 1, then remaining t would be, or target would be 1, and for this 2 we get t is equal to 0. It means it is satisfied here, right? Now for this t is equal to 1 we again take 1 and this is t is equal to 0, right? Now we have 3. So for this 3 we have only one possibility, that is 1, right? So for this 1 it's this should be 3, so the remaining would be t is equal to 1, and for this one we have only one possibility, that is 1, so this would give us t is equal to 0, right? So now you can see this, we have t is equal to 0 here, t is equal to 0 here, 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 here and here, right? So total t is equal to 0 is equal to 7. It is 1, 2, 3, 4, 5, 6 and 7. The total possible combinations is equal to 7, right? Now if we approach this question through a recursive way, right? So this recursive will tree will take around big of n to the power t. T is basically the number of target, right? So this will take bigger of n to the power t time complexity, right? So to optimize this time complexity we can use dynamic programming, which will take n into t as a time complexity, because as you can easily observe that there are some sub problems repeating again and again, right? Now what are these sub problems? Let's see. We can say this t is equal to 1 is repeating here, and this is repeating here. Similarly, this t is equal to 2 is here and t is equal to 2 is here, right? So this whole tree is again repeating, right? This is repeating, this whole tree is again repeating, right? So these are the repeating problems. So if we take this solution, or we can store this solution in a vector, so we can easily recall this value when we get t is equal to 2, so we don't need to traverse it again, right? So in this way we can reduce the time complexity, right? So this is the solution through dynamic programming, right? So let's quickly see how can we code this solution. I hope this approach is clear to you. This is pretty standard problem of DP, or we can say dynamic programming, which we usually do by first writing a recursive calls, then we just optimize the solution through DP by memoization, then with bottom to up approach, right? So let's quickly see. Let's first write the recursive solution for big O of n to the power t, then we will write the DP solution by memoization. So let's quickly write the recursive solution here. So for this, let's take a function solve, and this solve function will be taking vector. Let's take the same parameters from here and paste it here. All right, now what are the possible conditions, right? If target, right, like we have already seen, if the target is equal to 0, right? If the target is equal to 0, it means we have got our possible combination. So let's write the same statement here. If target is equal to 0, it means we need to return 1, because we just need to increase the count by 1 because we have got a possible combination, right? Now let's run a for loop to iterate through all the elements of this nums, right? Because we need to just traverse through 1, 2 and 3 to find the all the combinations, right? So let's quickly run a for loop for auto x nums, and let's also take one more variable int answer is equal to 0 initially, and here let's see if this x is less than equal to target, right? If it is less than equal to target, then only we can decrease the value of target in the next iteration, right? So let's quickly write answer plus equal to solve. Let's call the recursive call here, and solve, let's pass nums, and target will be reduced by x, right? We have done the same thing here. We just reduce the target in each step, right? Like we have taken 1 here, so earlier the target was 3 and we reduce by 1, so target is equal to 2. Similarly for this 2, we reduce the target by 2 in the next iteration, right? So we are just writing the same statement here, and at the end just return answer from here, right? And here let's call this function, so return solve, let's call nums and target, right? I hope this should work fine. Let's try to run this on a sample test cases. This is a brute force solution. Yeah, it's running fine. So this is a brute force solution. It will take the time complexity of big O of n to the power t, but this will give us time limit exceeded in some of the test cases. So let's optimize this through DP memoization. So what we do in DP memoization, we just make a vector or an array to store the values, to reduce the calling of, or to eliminate the calling of the same sub problems again and again. Like we have t is equal to 2 here, t is equal to 2 here, so it will just eliminate this sub problems from here, and it will just directly return the answer if we get t is equal to 2, right? So let's quickly make vector dp, and the value of, or we can say the size of this dp depends on the value of, like the value which is changing again and again, right? So you can easily observe that the value of target is changing, right? We are basically playing with the value of target here, right? So let's see the highest value of target. So highest value of target is 1000. Let's take 1 or 2 extra, so let's take 1002, and it's fine. Now let's set all the values to -1. So set dp -1 size of dp. All right, now let's do a memoization here. So in the memoization, what we do, we take dp target is equal to answer, so we just store the answer into this index so that we don't need to repeat it again and again, right? And now let's check if dp of target is does not equal to -1. It means we have already computed this value, right? So in this case we will be returning dp target, right? We will be returning the value of this index. So this is fine. Let's try to run this again. We just need to add one or two statements to convert this into the dp memoization. And now let's submit this. So yeah, it's working fine. So the time complexity of this solution is bigger of n into t, as we have already discussed here. This is n into t, and the space complexity is bigger of t, right? Because at max we are storing all the t elements into this dp, right? So I hope this approach and solution is clear to you. Let's quickly see one more optimized approach. We can optimize this approach by removing this recursive call. Rather than using this recursive call, we can use a for loop, because this recursive call is taking bigger of t space, or we can say auxiliary space, to store a recursive stack. So we can reduce this. So let's see that solution. So let me just make a comment here, and let's make a vector dp. So vector of int dp, and size would be target plus 1. Right, now let's make the initial element as 1. All right, and now let's run a for loop for the target value ranging from I is equal to 1 to I ranging till target. So target I plus plus. Now let's take the same logic here, because the logic is same, right? So we are just copy pasting this from this to here, right? The logic is same. We are just removing this recursive stack, right? So like we need to just update few things here, right? So for this target, right, for this target we are taking I as a ranging value from 1 to target. So let's replace this target with I here, this target with I here, right? Now for this answer, we were taking this into this dp target. So rather than taking it into dp target, we can take this into dp of I, right? I is basically the target here, right? For this recursive call, right, the basic aim to remove this recursive call, right? So to remove this recursive call, what we can do is we can directly take this into this dp, right? And this will work fine now, right? At the end, just return dp of target from here, right? And this will give us the correct solution. Now let's make the previous solution as comment, and let's try to run this on the sample test cases. Yeah, it's working fine. So the time and space complexity of this solution is same as the previous one. We are just eliminating a recursive stack from here. So this will reduce our time is our space complexity to some extent, but it's still the space complexity, or we can say the overall space complexity is bigger of t, because we are storing at max target elements into this vector. Right, so that is it for this video. I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.